Hey guys, today we're going to solve 2x2 systems of equations, and what that means is two equations with two different variables. So I've got two equations here, each one has an x and a y. So that's two equations with two different variables. And we're going to do this in three different ways. First, we're going to solve them by graphing. So this first equation, I've got a y-intercept of -5. So there's my first point. And the slope is 3, which means I go up 3 and right 1. And I'll put as many points as I can fit on the graph. Down 3 and left 1. Putting in that many points just helps me keep my slope all the way through. And the next line has a y-intercept of 6. And a slope of -2/3. So that's down 2 and right 3, which is also up 2 and left 3. So there's my second line. When you're solving systems of equations, what you're really doing is finding out where are these lines going to intersect. And these lines intersect right here at the point 3, 4. So the solution is that intersection, 3, 4. In number 2, we've got a y-intercept of 1 and a slope of -2. That's down 2 and right 1. As many times as I can. And then up 2 and left 1 as many times as I can. And the second line has a y-intercept of -5 and a slope of 1/2, up 1 and over 2, and down 1 and left 2. The intersection is right there, and here we see the downfall of solving by graphing, because that's not a set of integer coordinates. I honestly don't know what to call that coordinate right there. It's some decimal or fraction coordinate. I just don't know exactly what it is without being able to have a graphing calculator help me. So here is the downfall. If they intersect each other on integer coordinates, that's great. But if not, then graphing doesn't really tell us exactly what the solution is. So we'll try another method. Substitution. Substitution is great when there's a variable all by itself, or when it would be really easy to get a variable all by itself. In this case, I know that y equals that. So I can substitute that in for y right down here in the second equation. So this 4x minus 2y becomes 4x minus 2 times that value of y, 3x plus 5. Okay, so I can distribute this -2. -2 times 3 is -6x. -2 times 5 is -10. So I have like terms here. 4x minus 6x is -2x. And this -10, I can add that to the other side, and I'm going to get 22. And then I'll divide by -2. 22 divided by -2 is -11. So there is the value of x. I can choose to plug that into either equation. I'll do it in the top equation. Y equals 3 times -11 plus 5. So that's -33 plus 5, and -33 plus 5 is -28. So that is my value of y. Now I got that value of y by plugging into this top equation, so I know that's going to check out. That's going to be okay. But what I need to do in order to be sure that my answers are correct is plug these into the equation that I did not just use. 4 times -11 minus 2 times -28 should equal 12. In this case it does, so I know it checks out in that equation. But if I want to know that my answer is correct, I need to plug my answers into the equation that I did not just finish with. So I know that they work in both equations. Okay, next one. We've got x by itself, which means x has that value, and I can plug it in right there into the top equation. 3 times 2y plus 3 minus 5 equals 11. So I just substituted that in for x. So I'll distribute 6y plus 9 minus 5 equals 11. Okay, and that actually should be 5y. Okay, that's better. So I've got 6y minus 5y is 1y. And then I can subtract that 9 to the other side and get 2. So I get y equals 2. Okay, then I can substitute that into either of these equations. I think it would be easier in the bottom one to plug in there and for y and solve for x. 2 times 2 plus 3 equals x. So that's 4 plus 3, which is 7. I got that value of x by plugging into this equation, so I know that equation is going to check out. But I need to plug in my 2 and my 7 here. So 3 times 7 minus 5 times 2, which is 21 minus 10 equals 11. So I know it checks out there. So my solution is correct. Now what this means is that in number 3, these two lines would intersect at the point negative 11, negative 28. And these two lines here would intersect at the point 7, 2. So it's important to keep in mind that the solution is an intersection of these two lines. Okay, the third method is elimination. Okay, some people call it linear combination because you're combining the equations of two lines. Here I've got a 5y and a negative 5y. Those are opposites. When I combine these equations, 3 plus 7 is going to give me 10x. 5y minus 5y is 0, so those cancel. And 11 plus 9 is 20. So if I divide by 10, I get x equals 2. And I can choose to plug that into either the top or the bottom equation. I'll go with the top. 3 times 2 plus 5y equals 11. So that's 6 plus 5y equals 11. And I can subtract that 6 over to the other side. 5y equals 11 minus 6 is 5. And then divide by 5, and I get y equals 1. Okay? Now I got my second value by plugging into the top, so I'm certain that that works. But I need to plug in here also. 7 times 2 minus 5 times 1, that's 14 minus 5 is 9. That one checks out. So we should always check to make sure that our answers are correct. Okay, now the next one, I've got a 4y and a 4y. I want them to be opposite. So if I multiply, say, this bottom one by negative 1, what that does for me is it gives me a negative, negative, negative. So when I combine 6x minus 2x is 4x. The 4 and the negative 4y cancel, and 21 minus 13 is 8. So I get 4x equals 8, and when I divide both sides by 4, I find that x is 2. And I can plug that into either of the original equations. So let's go with the bottom one this time. 2 times 2 plus 4y equals 13. Okay, so I'm going to have 4 here, plus 4y is 13. Then I'll subtract that 4 to the other side. 4y equals 9. And when I divide, I get y equals 9/4. Okay, and I got that from plugging into this one. We should plug into this top one. Every time you do these, please plug into the one that you did not finish with and make sure it checks out in that equation also. Okay, I've got a 4 and a 2 and a 3 and a 6, so neither of those are really set to eliminate, but if I multiply And I'm going to do the y's because I've got a positive and a negative, so I'll multiply this one by 2, and then I'll have a positive 6 here for the y's. Okay, so that's one method. It's not the only one. I could have multiplied the bottom by negative 2, so I would have a negative 4x, and then I would eliminate the x's. But I'm choosing to eliminate the y's. I'm going to rewrite that down here. 8x plus 6y equals negative 2. So 2x and 8x is 10x. Negative 6y and positive 6y cancels. Negative 3 and negative 2 make negative 5. So when I divide by 10, I get negative 5 tenths, but that can be simplified to negative 1/2. So my value of x is negative 1/2. So I can plug that into the top or the bottom equation. I think the bottom one is what I'm going to go with this time. It really doesn't matter. 2 times negative 1/2 minus 6y equals negative 3. 2 times negative 1/2 is negative 1. So 2 times negative 1 is negative 1 minus 6y equals negative 3. So we're going to add that 1 and get negative 6y equals negative 2. And divide by negative 6. So we get y equals 1/3. Okay, now I got that by plugging into this one, so when we check, we got to make sure we're checking into this other equation. All right, number 8. There's nothing that's really set up to eliminate for me, so I can choose the x's or the y's. This time I'll do the x's. So what I'm going to do is, because I've got a 3 here and a 2 here, I'm going to multiply this one by 3 and this one by 2. And I'd like them to have opposite signs, so I'm just going to pick one of them and make it negative. So when I rewrite these, I've got 6x plus 10y equals 28. And I've got negative 6x minus 9y equals negative 21. So now I have eliminated the x's. And 10y minus 9y is 1y. And 28 minus 21 is 7. So I've got my value of y. I like the numbers better in the bottom equation, so I'm going to plug in there. 2x plus 3 times 7 equals 7. So I put that y value right there. I get 2x plus 21 equals 7. And I'll subtract that 21. 7 minus 21 is negative 14. And when I divide by 2, I get x is negative 7. I got that by plugging into the bottom equation, so I know that one works. When I check, I need to check and make sure it works in the top equation. Here, once again, nothing's really set to eliminate. I've got a positive, positive, negative, negative, so nothing's even got opposite signs. So I'm going to choose to eliminate the x's again. 1/3 times what number makes 5? Well, it takes 3 of them to make 1, and I need 5 of that, so it must take 15. So I'm going to multiply by 15. And I've got positive, positive, so I'll make that a negative 15. Okay, so the reason I'm using 15 is that 15 times 1 is 15, over 3 is 5, so that's going to eliminate for me. So when I bring that one down here, I will have negative 5x, then negative 15 times negative is positive, times 3 over 2, so I'm going to have 45 over 2. And then negative 15 times negative 4 is positive 60. Okay, so I'm going to bring this equation down here and rewrite it as 5x minus, and now I've got a 4y. I need to be able to combine that with this 45 halves, which should have a y on it. I need to be able to combine that 4 and the 45 halves. So in order to do that, I have to have a common denominator. So I need to make that so it has a denominator of 2. So I'm going to take that 4 and multiply by 2 over 2, and I'm going to have 8 halves. Okay, so my only reason for rewriting this one is to have a common denominator. So the x's eliminate. 45 halves plus 8 halves, or plus negative 8 halves, is 37 halves. And 60 plus 14 is 74. Then to eliminate this, I need to multiply by the reciprocal, 2 over 37. 37 happens to go into 74 2 times, so I'm really doing 2 times 2, which is 4. So my value of y is 4. And our last one, I could eliminate the x's by multiplying by a negative 3. So I get negative 9x and negative 15y and negative 33. And now my x's have canceled, but so have my y's. So I get 0 equals negative 16. And that's not true, which means there is no solution. And there's no solution because these two lines are parallel, which means they will never intersect, so I can't find an intersection. If you happen to be doing one of these problems and say you get 0 equals 0, that means there's actually an infinite number of solutions because they would be coinciding lines. So one line lies right on top of the other, which means that every point along those lines, which is an infinite number of points, would count as a solution.